Hi everyone, once again welcome back to the channel. In this video we are going to do the AWS 3-tier Terraform project. In this project we are using the Packer to build the AMI image, and the Terraform we are structuring the infrastructure by using the Terraform blocks, and we are storing the TF state in the S3 bucket. All those things we are doing in the Terraform. Okay, we are not doing any manual work here. Just with the help of single command we are executing this infrastructure. This infrastructure I did it already. This is my personal website arishanshetty.github.io. Here in the left side we can see the projects. Click on the projects here. You can filter it out what project you like to watch. Basically this project is in the AWS project section. Here the project is same. This is the AWS workshop project officially from the AWS. I just did it. This is the basic project, and just I improvised the project the same with my infrastructure. This project going to cover the 15 plus services. This is the visual way, the same what we are doing in the Terraform. Okay, if we have any confusion in this Terraform project, I am recommending you go through with this project. The everything is detailed and you will figure it out what you have to do. Otherwise, if you have a knowledge in the Terraform, you can watch this video. Okay, and here the data is every time when we are launching the new instance, as in the ASG auto scaling group, every time it's going to fetch the new data and building that node applications and serving to you with the help of the application load balancer. And here we are doing the RDS MySQL in the 2 availability zones, and the ASGs we are doing the app tier in the 3 availability zones as seen in the image, and the web tier also we are making the 3 instances with the help of the ASG. And these 3 tiers, web tier, app tier, DB tier, everything is the private subnets. The only part the front end ALB is in the public subnet. Why? Means we have to access the website for the front end application. That's why we are using the public subnet in the front end load balancer. And one more thing, we are using the backend ALB internal load balancer is going to check the internal load balancer and accessing this instances data. Okay, API data. Okay, we are using the internal ALB also and the external front end ALB also in this project. And this is the project folder structure. We are not merging all the files and making large block of script here. We are segregated network section, database section, compute section, and the storage section. In this project we are not using the storage section. You can, if you like to improvise this project, you can use it. Basically I am not doing in the any storage section here, not going to touch. We are going to touching the only network, database, and the compute. We have to follow the first, we have to set up the network section first, and database section and the compute section. If you done compute section, database section, network section, this project not going to work. Okay, and this project we have to install some applications. We have to install, first we have to install the Terraform and Packer, AWS CLI, JQ, and the Git. These are the application we have to install it. And this project, when you are executing it, Terraform apply is going to take approximately 20 minutes. Okay, you have to wait it. Basically I just spent for this project almost $10. You can see in my bill account here. In your case you have to spend at least $1 maybe. See, at least I spend this is not exact amount what I spend it in this project. This is all our project bill amount. Okay, and okay, I'm going to exploring it here. I monitored here. See, in the NAT section I spent the $14 approximately. I know I monitored it. Approximately I spent at least $8 I guess. So in your case you have to spend at least $1. Okay, and that's it. And one more, what we have to do, you have to create this name of the new key pair. This name of the key pair you have to create, otherwise it will not going to work. If you want to create your own, means you have to replace in your infrastructure project, you have to do it. Okay, I will show in the key pair. First thing, EC2, first EC2. If you like to do project in your machines, means you have to practice, means you have to create the key pair first. You can use it, your key pair, not an issue, but you have to replace all the things, not Virginia, not Mumbai. And keep in mind, this project is basically in the AP South 1, not in any other region, AP South 1. Okay, and this is the key pair, new key pair. If you don't have, just create the key pair with the name of this name. Okay, and this you have to keep in mind. I will paste it in the notepad section here, and take one of the notepad, and we in this project we are just not doing the project, we are also learning some important command also. Okay, that's why I'm saying just copy paste the commands, you will guys going to help in the future. And let's go into install the Terraform. The Terraform I given the reference here. If you don't believe this link, means go through with the Google and type it Terraform install, you will get the link. Okay, this is the official link, and make sure what architecture you are using. Right now I am using the Ubuntu machine. If you don't have the Ubuntu, means you can create one of the instance Ubuntu in the AWS console manually. Okay, otherwise if you are using the CentOS Mac, you can use it. Okay, right now my machine is Ubuntu, so I have to install this command. The same command I am just write it down here and open the terminal, paste it, and make sure all the required application is installed in your machine. Actually I already installed, that's why it's getting the error, not an issue. And we have to install the AWS CLI also. This is also you have to go with the official documentation for the latest command. Yeah, this is the latest command. Okay, and the same command I am just here. For this AWS CLI installation, you have to install the unzip. If you not installed it, why, means this is a zip folder, that's why I am saying just install it. In my machine already installed. For you guys purpose I am repeating once again, that's it. And once again cross check it whether is installed or Terraform is installed, and the JQ is also installed. Git also installed, and AWS CLI, AWS also installed. Okay, all the things is Packer. The Packer thing you have to check, the Packer also installed. See, when you type a Packer, he means you will get the Packer. If you like to see means exact version, Packer, I will paste it in the notepad here. Packer. Okay, Packer is the main thing in this project. I am saying once again, why, means is going to create automatically. That's why AMI image, that's why we need a Packer. Okay, I will show you in the step by step manner. And now we have to create the what access key. Okay, Let's go to the IAM here. Users. This is the user account, normal user account, not a root account. Okay, make sure you are using the normal user account, not the root account. And this account have the administrator access. Go select the security credentials here and click on the create access key. Create access key. Okay, select the command line CLI. Understood. Next, create. So it's going to display the access key and the secret key here. AWS CL configure. Now copy paste the both secret key, access key, and we are using this project in the AP South 1. You can enter it by defaultly, but and JSON the format for the output. Okay, so we entered everything. Okay, done. Just download the secret key, access key for the safety purpose. Once it's done, click on the done. Okay, now let's move on to the next. See here, when you are using the GitHub repo in your personal GitHub repo, you have to replace all the things. Okay, because why means I am saying because the bucket name is unique for the global. I will show here my bucket. Presently I am going to give this bucket name. I will show here once again. There is no bucket in my account. Okay, just I am going to cloning it. 1 second, just clone here, clone in your machine. Use the Visual Studio Code, is going to help, because if you are doing manual you can't able to do it in a easy way. So I will show the one of the small trick here to replace all the things. Okay, and first thing, the bucket name you have to should be unique. First what you have to do, go to the S3 bucket here, first test it whether is this bucket is available in the global. Okay, first test it, then what you do, then you replace that bucket name here, backend bootstrap main. Here replace this, what you tested is available in the global. Once you tested, you deleted this bucket and the same bucket name replace here. Okay, in the future I am deleting this bucket, you can use it. Otherwise some users is doing this project means they keep this bucket as a permanently. That's why I am saying if someone using this bucket name, you can't able to do this project. That's why you have to replace it. Just copy it. What you do, your bucket name, and click on this icon, search icon. This is the Visual Studio search lens. When you type this, is going to search all the files in your machine. It's taking some time because it's scanning your locally indexed folders. That's why. It's going to show all the details here. See, is going to show all where it is this buckets is available. It is also available in the backend bootstrap, and you can see the Terraform compute section in the backend file. It is there. Okay, backend file, and it is also available in the variable Terraform file. Once you're done, just paste your unique bucket name here. Okay, your unique bucket name. Okay, once you click on this one, is going to replace all the related to the bucket name. Okay, if you're doing the project in your local machine, we can easily execute this project within a single command, but you can't able to understand what we are going to do in this project. That's why I'm going to show one by one, step by step. Okay, let's move on to the next. Now what we have to do, and the source AMI, the source AMI packer. Now I'm going to show the packer section. In the packer section here, we just seen the backend, right? There is no S3 bucket as well as the DynamoDB here. There is no table here, and the items also there is nothing. Okay, we just explored it, this section. Now we have to see the packer section here. In the packer, what I did here in the front end JSON, you can observe here, this is the AMI image what I taken from the EC2 instance. Here go select the AMI catalog, and here you will show the number of catalogs here, AMI images, and this is the image right now I just taken. Okay, this is the same image 8A86. You can see 8A86. Right now in this AMI image is available in this repository. In the future, I don't know it will available or not. In the future, if you are doing this project, means make sure you just replace this Amazon Linux, not any another Ubuntu, CentOS, Red Hat, like that. You have to make sure Amazon Linux and with this image ID. That's it. You just have to replace it. Now right now don't replace it, it will work. In the future I am saying, that's it. In this section, what we are going to do, I set the variable AP South1, create the AMI image in the AP South1, and with the AMI image ID here, source ID, use the T3 micro, and the username is EC2 user project. I am just giving the tags here. In the provisional, what I am going to do here, I am just installing Nginx here, Nginx as well as the NVM 22 version. Okay, in this project the front end uses the React, the back end uses the Node. That's why I'm using this provisional Nginx as well as the NVM. That's it. Okay, now what we have to do, I will show the custom build of the packer. There is a command. In the downside, you can see the packer for the testing purpose. If you have a time, means just to explore it and test it whether it is working or not. And this is the command. Just copy it here and move to the folder. This is the folder, right? And ls. Where is the packer? This is the packer section, and and paste it. Let's move on to this path and go into executing it. One more thing I will going to show here, there is no AMI image currently in my account. There is no AMI image. Okay, what I'm going to do, just I'm going to executing it. Now what we're going to do, this means is going to create one of the custom AMI image for this project, is going to help. So it takes up to almost 5 minutes going to take. Let's explore another things here. I will come back once it's done. Okay, we seen this S3 bucket, but we are not created, right? So let's go into create and take one more terminal here. bash new terminal. Okay, new terminal. I just taken one of the terminal here. Okay, move to the 3 tier and backend. One more thing you have to observe here, one thing, take okay, move back here, du search star in this section. What you do, observe what will happening here and note it down in the notepad. Starting project size. Okay, this is the size of the current. Let's create this section. Let's move to the backend here. cd backend bootstrap. We have only 2 main and the versions, right? In the version here, I'm just given the provider as AWS 6.0 version. If you need exact this version, means go to the Google here and type AWS provider Terraform. Okay, here you will get AWS provider Terraform registry. In the top you will get the versions here. Okay, currently right now we have the 6.14. okay, so what here also you can find out the Terraform script here. You can just copy paste in your script, Terraform script. What we have to do, okay, now we see in this section, right, is going to create the in the AP South one and with the DynamoDB table name Terraform logs, and we are billing to the paper request hash key. We are using the log ID. Make sure you should be like in the this format only, log ID, and the tag, everything is okay. And the name, bucket name, we are giving this bucket name. Again I am saying just replace this bucket name, otherwise this project is going to work in your machine. And we are enabling the versioning also here. Okay, we are enabling the versioning, and we are also encrypting this version stored TF state. Okay, let's try to create the S3 bucket and the DynamoDB here. What we have to do, Terraform init. We have to download the plugins related to the AWS. That's why we have to initiate the Terraform init. See, finding the HashiCorp AWS version above the 6.0 is going to installing the version 6.14 as seen in the web console. Okay, see, we have to observe all the things. Just we are blindly we can't able to do the command executions. We have to observe all the things. See, okay, come back here. See, now the backend bootstrap is consumed 700 MB. What is there in the initial stage? It is 12 KB. Okay, now is 700 MB is occupied because the AWS plugins is installed in your local machine. Okay, that's it. We have to observe like this. Okay, done. And let's see, is there a created or what in the S3 bucket is created. Oh, still we did not apply it, right? So sorry, my bad. Backend Terraform plan. Oh, this is also done. Here my image, let's explore that one. And now the backend is going to hide the 4 services. Okay, Terraform apply auto approve. Why I'm giving auto approve means if something is in middle is going to ask the S option, so when you given the auto approve is not going to ask the S command to manual entry. Done. Let's cross check it here. S3 bucket just now is created, is empty. Okay, just is simple empty. And check the tables here in the DynamoDB. Tables also created here, and explore items is Terraform logs. Okay, done. Now this section is over, and we did also S3 bucket DynamoDB everything, and replace it if you are creating the S bucket. We just cloned also. We did this also, Packer also we explored it, right? And now let's cross check it once again. AMI here, you can see here, you can see one of the AMI image is created because of this manual command. This command is builded the AMI image. Let's cross check it whether is Nginx is installed or what. Launch instance from AMI web. Okay, 3-tier front end, 2T micro, new key pair, and default VPC. This is okay, default, and everything is okay. Done. Launch instance. Yeah, the instance is up now. So still we are not configure the infra. Before configure the infra, we have to cross check it each and everything first thing. After we can execute the infra. Okay, now let's try to access the web, whether the Nginx is installed or not. You can see Nginx is installed in this AMI, custom AMI. Let's try to connect it and check whether is a NVM is node installed or what, and make sure use your keys where you have, and just replace this name root to EC2 user. Login it. Once cross check sudo systemctl status Nginx is perfectly working, and NVM v, yeah, npm v. See, everything is installed. Node v. I said the command install the 22 node, installed it. See, okay, we have the AMI. So this AMI is not going to work in this project. This is for the testing purpose we have just seen. That's it, just terminate it once you explore this option. This is for the only for the testing purpose. Okay, once you're done, click on the AMI here, select the custom AMI packed image, and click on the actions, deregister AMI, and make sure you selected this option, delete associated snapshots, deregister. Okay, done. Let's move on to the next thing. Script. Okay, now let's move on to the scripting section. we just executed this command only in the backend bootstrap. We are not using this command anywhere in this project. I just improvised the script here. This script is going to handle all the infrastructure with this single command. Okay, you have to observe each and everything in this project. The key pair you can see, that's why I'm saying you have to keep in mind, you have to create with the name of this key pair, otherwise you have to replace it in every file. Okay, now first in this apply.sh, first what is going to do is going to the network folder section, is going to initiate the Terraform and applying it, and move on to the storage section. In this storage section we are not using any blocks here, just simple. And database sections also same thing, step by step is going to do. If you do the compute section, database section is not going to work. That's why I'm saying you have to come from the network, database and the compute section. And once the database is created, is going to create the AMI image. Okay, I will show AMI image one moment. What we're going to do, when you are creating AMI image, what you do, you just store this front-end AMI.txt, store the AMI image ID in this path. Okay, we are saying store this in this path and execute this build AMI. Okay, and the same thing is we are saying store this backend AMI.txt in this folder, compute section folder. Done, everything is done. Now ELB section compute, the key name is going to use that what I said in the that one, and everything is done. This is a simple, just Terraform init and the Terraform apply, that's it. We have to check the cross check it whether is command is going to execute properly or what. Okay, let's move on to the which section, let's Packer section here. Packer section we've seen, right? Okay, let's move on to the network section. In the version, as I say in the previous, you can find out the AWS provider, what version you would like to use. We have to use the version, backend, variables, Terraform, TF variables, main and the output. Okay, version, backend. In the backend, we are not storing in the local TF state file. In this path, we are not storing the Terraform TF state. We are storing this one in the S3 bucket network section. I will show this is now right now is a blank, where my bucket is available in the AP South 1. My bucket name look like this, and store the Terraform TF state in this bucket with the folder path name is network. Okay, now move on to the variables. This is the variables we have to give, you guys know, right? And here the each subnet is I am going to give this separate one. I am not mixed up here all the subnets, the private database, everything, and the availability zones also I am giving this separate. And the TF variables I am just given the like this to make a changes easily, so I am given like this. So this is a beginner friendly video. This is not going to help in the production, but you can understand easily. Now once you the Terraform TF vars is everything is done, you can also change your own what I say network. If you have if you're thinking a 192 series, you can give it CIDA block. And let's move to the main now. You can see now we are creating the 3 NAT gateways, not 1 NAT gateways. We are creating the 3 NAT gateways, 3 elastic IPs in this project as shown in the image here. 3 NAT gateways we are creating, 3 elastic IP also we are creating. Let's move on now. Yeah, you can guys know internet gateway, subnet, public subnet 1A, 1B and the 1C. Okay, like I am also defining here variable is where the public subnet 1A should be in the AZ1, public subnet 1B should be in the AZ2. The same like that I am just followed here. That's why I am saying if you have a doubt means watch this video. The same thing, the what we are doing in this Terraform project, the same thing I deployed here in the visual way, you can understand easily. Okay, the private subnet sections also same thing. Private web private subnet 1A is in the AZ1 and CIDR block I am giving the private subnet AZ1. Everything is same. This thing you not going to change any values here. Just you have to replace the GitHub repo as well as the name of the key pair. That's it. Everything is same here. Elastic IP, see, elastic IP NAT1, NAT1, NAT2, NAT3, okay, NAT gateway 1A3 and assigning public subnet 1 NAT gateway. If you have a lot of confusions means I am not using here the count and the for each, I am just directly writing blocks. Okay, for beginners is going to easy to understand all these things. And the associate also, route table also I am just created the 12 route tables associates here. You can explore it. See, for each subnets I am just created the separate table associations. And the security part, what I am going to say here. So where it is security part, this section, this one I am going to paste in my read file after this project ready. Yeah, this is the part of the security group. The same part I just did it in this Terraform. Okay, same, and this section is going to confuse your Terraform blocks. That's why just cross check it. If you don't understand this section means just observe what the things is we are applying in the security section, security group sections. We are giving the name 1 2 3 4. Okay, web front end ALB is 80 exposing to the world, and the web security group only accessing from the front ALB, no accessing from the external world. Okay, and internal ALB accessing only from the web server, not from the front end load balancer. And the app server internal, what I am saying is this image have the access AP internal ALB with the port of the 4000. The node API logic works in the 4000 port. Okay, and the DB server accessing by the AP south. Even the front end service group don't have a access to the database. Okay, and if you have a confusions here, I just drop down here. When you are creating the flow here, the front end security group, internal app security group, there is same thing. I given the number here, the same number I just given here. Just I am just not applying the 5 here. The same 1 2 3 4 is here, 1 2 3 4 5 in the left side. That's it. The same subnet everything I just did it in the Terraform. Then same thing. Yeah, and the output, this is the main thing. The output is going to help in the next of the coming section, compute section and the database section. I will going to show how they going to help this output section. Don't ignore these output sections. Okay, now the network part is over. Let's move on to the next part. Which part? Database part. database part, the same. First we have to go check the versions, backend, storing the backend in the database Terraform format in the separate path. Okay, now move on to the data. Okay, now data, what I am saying here, this is the separate file data.tf. in this file we are saying there is a network. For database we have to create this subnet, right, subnet group for the RDS, right. So there is a file network terraform.tf style in the S3 bucket. Okay, take that information, with that information create one of the subnet group for the RDS. Okay, with the help of this data file is going to capture the data you already created the subnets. That's why I gave on the back data here, the backend S3 I just defined here. Okay, you have to observe all the things here like that, and the variables the same. This is simple variables, you guys know already, and the database allocation storage I given the 20 GB here. That's it, and everything is okay. And the MySQL is 8.0, database engine is MySQL, and instance class is db3 micro. Same what we are doing in the console, same thing we are doing in the Terraform. That's it. And gp2 string. Okay, here we given the all the details of the variable. Okay, done. And let's move on to the main section. And the main section subnet IDs, private subnet 1A, private subnet 1B, private I am just giving the all three private subnets, database private subnet, not the other web or app. Okay, so once the subnet group is created, is going to create the instance of the RDS MySQL. We gave on the variables defined in the Terraform and the variables, right. Is going to check all the things variables in the backend. Maximum allocation storage is 100. This is simple. Okay, that's it. Is only 64 lines is here in this section. Okay, done. And the output is this one also going to help in the compute section. That's why. And observe here, RDS address, RDS endpoint, RDS port, RDS username. This will going to help in the compute section. Now the database section is done. Now let's move on to the compute section now. Compute section. In the compute section, the same. Okay, backend. Okay, and here in the compute section, we need the network details, right, and as well as the database details. So for the network details we need to assign the instance in the particular network subnets, private subnets or public subnet, like that. And the database we have to know what of the RDS address and the username password what they have. So that's why we need the database section TF file state. This is TF section, nothing like a brain of this Terraform. And local file, I'm just given a backend AMI here. Done. Let's move on to the variables. This is a simple, see the key name, DB password is going to check everything. Let's move on to here. Here I given the simple. This is the key name. I am going to use the new key pair. Web instance use the T3 micro. The C's block is used for the ASG auto scaling group. And right now I gave on the 1. If in case is move on to the CPU utilization high, 50% or 60% is going to cross. CPU utilization means is going to increasing the instance automatically. The same way I gave on the app instance also. The DB password is I'm just giving the simple password, and the Terraform state bucket is this one. Okay, done. Let's move on to the main section now. Okay, the ALB, AWS ALB web. This is the load balancer. Okay, AWS LB load balancer. In the load balancer, I am giving the public subnet. See, the load balancer should be in the public subnet, right? Not in the private subnet. So we have to access the data. That's why I gave on the public subnet in all the 3 availability zones. And the ALB here, target group web, the port is 80. Okay, the port is 80 because we are using the Nginx and the run build image. I will show in a moment why we are using the 80 and this thing. And okay, this is done, and the listener is also 80. Same what you are doing in the console, AWS console, same thing. The launch template, is also same. The launch template is nothing but, I said in the previous, there is a information, you created the data here, what you created the data here, frontend underscore ami.txt. It is available in this folder, in this path. Okay, it will going to create in this path. I will go to show in a moment. And the key pair you can see, and the network security group I just defined here. Take the output from the network section. We defined the security group in the network section, right? So in the data is going to capture it here from, this is the security group ID, you have to handle it, just given, not the ALB. This is the security web only security group. And the user data, web user data. Guys, do you remember the user data? You are just giving it there. I will show in a moment here. When you are creating the instance, launch instance, when you are filling all the details, advanced details in the down, you will see the user data. This is the last. You will write something apt install nginx, right? Correct now. The same way we are using the here web user data.sh. In this file is going to attach here this path, this path, it is going to paste it like this here in the launch template, not in the instance, in the launch template. Okay, here what I am saying, for the cross verification purpose, for safety purpose, I am just reinstalling the Nginx, not going to install. For the safety purpose, going to install it. Is going to clone the repo. This is the repo of the project. See, my profile. This is the my profile. If you are doing your manual in your machines, you have to create your own repo and replace all the things. What I say in the starting, you have to replace all the GitHub repo and the file, everything. And this one also you have to replace it. Okay, and copy from this path to web.sh to the EC2 user web.sh, and here is going to replace the application load balancer DNS into this Nginx file. I am going to show right now here where it is application web. I know guys, you will get something a little bit confusions in this project, I know, but when you are doing the project you will figure it out what the things we have to do. I know there is a little bit complex and little bit confusions in this project. I know you will figure it out when you are doing the projects. When you get a error means you will easily figure it out. You just go with the DeepSeek or ChatGPT. Okay, copy from this web files what we have. This is a web file. There is contain some files here, React files, and move to the that file with the help of cd and give the permission EC2 users for that folder and owner group, everything. And there what you do the installation of the dependencies for the React and build the image, build the website inside over there. Every time when the new instance is going to create, every time is going to create. Okay, now where we are left here, the app ALB DNS is going to replace your internal DNS address automatically, where it is web, not web nginx. See, it will going to replace your internal app DNS address here and moving that file to the nginx folder. Okay, it may be going to confuse in this part. You will figure it out once you doing. Okay, don't get confusions. The web user data is finished. Now app user data, the same way we are just doing it here, but the part is different. We are not manually inserting the data here. Observe, we are inserting data with the help of this initialize database command. Is going to initializing the data. Okay, with the help of these commands, it captures the RDS RDS address and the username and the password. Is going to adding it, the database automatically is going to add. And the same thing you will figure it out if you know the command means. Okay, done. And one more, here we have to replace the database configuration, and this command is going to useful for the future cases. Somebody knows this command. This sit command is going to replace the files. Okay, use this sit command, write it down or copy it in the notepad. Okay, I will show in the database. Right now there is some value here present. When you start the instance, is going to replace all the details. Okay, with the help of the sit command. Okay, now app dot this one also we done. Okay, once everything is done, now what you have to do, just execute this ap.sh. We are saying just execute once you done inserting the data as well as the replacing the value of the database config. Just execute this app.sh. Okay, here the command is simple, giving the permission to this EC2 user folders and execute inside here. Install the AWS SDK as well as the MySQL to support and access, and install the dependencies and fix the dependencies and start the help of the PM2. Okay, where you can ask me where is the PM2 we are installing here. That's why we installed in the while creating the AMI image here. This is the backend.json, right? This is the also Linux image. Here we install in the nvm install 22. Along with we are installing the npm install PM2. Install this one. We are saying already in the AMI while creating the image. So that's why we are not doing it. Once you done, start this and up and run this PM2 index.js. Once it done, in every if in case instance is rebooted or crashed or restarted, we can't able to manually enter into the machine and start that instance.js. Okay, that's why when you rebooted the instance, this command is going to help. Even you restarted the instance, is going to start your application, backend application. This is the backend files. Okay, done. Now we've seen all the things, right? Terraform, we explored it. Okay, one more thing you have to observe here, git.ignore. Don't ignore this file, otherwise you have to can't able to do your project. Why means, just I said in the previous, see, du-sh store, see this file 784 MB where it is backend version is going to store all the details here. Okay, so when you push to the GitHub repo from your local machine to your GitHub repo, it's going to fail. That's why you have to set all this files name .terraform, .tfstate, everything. Okay, Terraform state we are storing in the S3 bucket. Okay, keep in mind, and let's try to execute it. This is the explanation is over now. This infrastructure may be going to take up to 20 minutes. Apply, where it is, where am I now? Okay, apply.sh. apply.sh, and also once again there is nothing in my S3 bucket, as well as the no tables in my DynamoDB. Now execute it. Okay, now you can see it captures the S3 bucket and storing the value over there. Network tf state is not here, installing it. Yeah, even I am not touching anything here. I am not doing any Terraform init, Terraform plan, Terraform apply. I am not doing anything. Just I wrote the script, step by step is going to creating it. Let's cross check it in here. Still not created, right? Once you modified any file, you have to push your local modified files to the GitHub repo. Okay, see now just they're creating the NAT gateway in all the availability zones, NAT1 A, B, C. Okay, let's try to see whether it's created or what. VPC, yeah, VPC is created, and subnets, see all subnets are created. 12 subnets is created. Okay, 12 subnets are created, and route table still not created. Internet gateway is created and attached. Elastic IP, 3 elastic IP is created, 3 availability zones, not in the single availability zones. Okay, and NAT gateway also is going to creating it. Done. NAT gateway also done, and route table is going to creating it. See, route table also done, is associating route table. You can also cross check it here. Route table, this is a private, right? The NAT gateway is attached, and this subnets also is attached. See, I am going to selecting the public. Where is public? Yeah, public. I am just selecting public. Is internet gateway is attached here. It is still creating. Okay, NAT is still creating one of the NAT gateways here. Okay. Done. Now it's moving to the RDS. See, the network folder path is created. Here Terraform.tf is stored. Oh, space is not available in my machine. Okay, let's, now it's creating the database instance. First cross check it here and refresh the first DynamoDB. Tables, actions. Active state, yeah. Okay, RDS subnet group. See, the subnet group is created and it is in the all availability zones 1 A B C. Okay, then 11 12 what we given here, Terraform network, not network, yeah, network section variables, this section. Okay, then 11 12 given, and database is still creating, backing up. This endpoint is created. Okay, so database take approximate 7 minutes. Done, this one is done, but the what I want to say, let's see here, done, and EC2. Actually, this is a raw content video. I am not going to even editing any single point of time frame. Just straight away I am going to uploading this video in the YouTube. Even I'm not going to add any musics, text files, nothing. Not here, AMI image. Yeah, what will happen now? Yeah, you can see here RDS instance is now just created. Yeah, is available. Yeah, is available. And now you see here the front end AMI is created. Now I will going to show where it is. Compute section, here. Observe here one thing, what I say in the previous, this folder should be in this compute section. In the apply, it is apply. That's why I'm saying once you find this file, don't again create the AMI image. Okay, just observe in this folder section is going to create one of this file. Backend and front end both is going to creating it. It takes approximate 5 minutes it takes. Okay, now instance is still, it should be in the available state. So now you can see the instance is up and run, and just clear the instance. And what will happen here, move back to the AMI, is going to creating it here. It should come to the available state, not in the pending state. The same way I will show once again. Once it done, the backend also is going to create automatically here. Right now there is no instance is running. Let's wait for a few minutes. See the output, what I am saying is the output RDS address. This is also going to help in your project. If you are not defined any variable of the outputs of the any network section or RDS section, that will not going to help. Okay, now it should be in the available state. Okay, if you like to do this some DevOps project, just filter it out here in my website. This is the website link. I will give it in the description box below, not a worry. And here click on the DevSecOps, filter it out. You will find out some DevSecOps related projects. You can also do it in the self-hosted runner or managed hosted runner, GitHub's action project, as well as the DevSecOps project. You will find out some more interesting here. We are not just creating the Jenkins pipeline, we are creating the EKS cluster and Argo CD we are using in this project. Okay, you can watch it later if you have any interest by doing the DevOps. Okay, now the AMI image is created. Let's see AMI ID. See, observe here what I said. Now just AMI ID is created in the front end AMI.txt. Okay, you have to observe all the things. Backend is installing the packages. Okay, the front end is available right now. The instance for the backend is creating it here. Okay, see, instance is creating, up and running right now. Is now you can see waiting for the instance to stop. See, now they are going to shutdowning the instance and creating the AMI image. In this image we are installing the MySQL, okay, MySQL as well as the node. I will show in the backend here. This is the command. We are installing the MySQL client, not installing the overall or all MySQL community. We are just installing the client to access the database, right? So we are just installing it and installing the NVM also same. Okay, now let's refresh it. The instance is now just going to stopping it once it done. Now go to the AMI. It's pending, so it should be in the available state. Backend is still on moving. It takes approximate 20 minutes. You have to wait, guys. Okay, and cleaning also you should have in the destroy. This is this simple destroy command. The same way is going to destroy all the things. The one thing we have to manually clean up the snapshots. AMI snapshot is not going to deleting that snapshot. By intentionally I just leave that. We can do by using the script. Okay, destroy. First thing in the destroy, in the reverse order there is going to do. First thing they do going to destroy the compute section and the database section and the storage section. Now the image of the backend is just created. Okay, now is moving on to the compute section infrastructure. As you see, okay, the backend AMI is done and creating the compute infrastructure is creating only the compute section. See, it's creating. Yeah, both AMI image is available. Let's try to cross check it. Launch template. See, one of the launch template is created. The app template, this is the app template, and load balancer we will check it later. Okay, let's check it right now. See, the load balancer is provisioning, and you have to check in the target group. Maybe you have to check the this target group in the app. You have to cross check it. What you given, the port is 4000, not the 80, 4000. The port is 4000. Make sure. I will cross check it here. Main, find it. See, app is 4000. Some people what going to do, they give only the 80. That's why we have to give what the application is earning. In the security group also same thing, we have to give it. Now the load balancer is going to provisioning now. Done. You should be come to the active state. Auto scaling group. Auto scaling group is app is creating it. Yeah, the command is successfully executed, and you can see all the details about the ALB and the ASG, and this is the web ALB DNS address. You can also take it from here. Otherwise, if you don't if you have confusion means click on the load balancer and click on this web ALB and copy the DNS address. Once it's done, execute it. Here you can see we are able to access the front end load balancer. Let's try to add some data. Okay, this is sample data. Now I'm going to add some data here. Right. Okay, data is now adding. See, even we are not added any single manual step in this project right now. So you can also do it the projects, but make sure you replace the correct of the S3 bucket as well as the GitHub repo and the key pair name. And see here in the separate sections they created the compute as well as the database as well as the network. Okay, each section they have own TF state. This is like a brain of your Terraform. Okay, we explored all the things, right? And let's cross check it how much space is now consumed. Let's cross check it now. See, this is the file, right? Copy and just compare it here. Earlier in the starting stage we have only Terraform file is 136 KB. We have only Terraform files. Now they occupy 2.4 GB of the Terraform. Why means we download the plugins related to the AWS, that's why is occupied the space 2.4 GB. Like that you have to observe everything. Okay, is going to consume the data spaces. I will move on to the Terraform here again. Yeah, each section is going to taking the size. Okay, let's move on to this section. What we explored everything, nothing is left to check it. Done. Yeah, load balancer, and we are accessing the data also, and you can also connect me. I gave on the link here. You can also check it out when you click on this options. Is moving on to my repos, and connect me in the LinkedIn and message me if you have any doubt. This is my LinkedIn profile, you will get it, and this is my GitHub profile also. Just follow me on the GitHub. Yeah, we just done all the things right without any manual interaction. Only we have to replace some related to the GitHub bucket and the key pair name. That's it. We've seen all the things in this project. I hope you enjoyed this video. If you like this video, like and subscribe the channel and comment it out what the problem you are facing. Okay, and don't miss out. If you like to explore more projects in the future, you can go to my website arishanshetty.github.io. This is my personal website, and the projects you can explore other projects also. Okay, and one more, if you are a beginner, you can also test this scripting tool also. Now this scripting tool is developing stage. Now you can see it by simple for Ansible projects. You can also explore it these commands, and Jenkins for the basics. This is all it is in development stage. In the future I am going to make a real world pipelines structures and DevSecOps also, everything. Okay, once again thanks you for watching my video. If you like this video, like and subscribe channel and share across your group sections. And once again, thanks.